GATE 2016 Civil Engineering Set 2 Question 34. A rigid member ACB is shown in the figure. The member is supported at A and B by pinned and guided roller supports respectively. A force P acts at C as shown. Let RAH and RBH be the horizontal reactions at support A and B respectively, and RAV be the vertical reaction at support A. Self-weight of the member may be ignored. Which one of the following sets gives the correct magnitudes of RAV, RBH and RAH? The relevant NPTEL reference has been mentioned. So when we discuss the static equilibrium for a rigid body, there are namely three conditions that need to be satisfied. The first one is that the sum of horizontal forces acting on the body should be equal to 0. The second one is when we subject all the forces along the vertical direction, their sum should be 0. And similarly, the sum of all the moments on the body about any point should turn out to be 0. If these three conditions 1, 2 and 3 are satisfied for a body, it is said to be in static equilibrium. In this case, we can see this rod which is connected at A and B. B is a roller support, so it will not have any vertical reaction. The only value will be a horizontal reaction. Let us call it RBH. The vertical reaction at A will be called as RAV, and let us call the horizontal reaction at AB RAH. So using the formula, that is the first one, which is the sum of horizontal forces on the body should be 0, we can see that the horizontal forces on the body are RBH and RAH. So RBH, since RAH in the opposite direction, we will take it as minus equals 0. So this will give RBH equals to RAH. This signifies that the magnitude of these two forces will be equal. The second condition that we will use is the sum of vertical forces should be 0. So we can see that the body has two vertical forces, P and RAV. So assuming upward direction to be positive, RAV minus P will be 0. So this gives us the magnitude of RAV, which is equal to P. We will call this our second condition. Next, what we need to do is the summation of moments about any point equals 0. So for the purpose of simplicity, we will take the moments about A to be 0, so that we don't need to consider the moments of RAV and RAH. So considering the moments of only RBH and P, so RBH is at a distance of 8 meters in total from A. So into 8, the moment of RBH and P will be in the same direction. So adding them plus P into P is at a distance of 1.5 meter from A. 1.5 equals 0. This would give the value of RBH as minus 1.5 P by 8. This is our third equation. So we can see that we know the value of RAV, that is P. We know the value of RBH, that is minus 1.5 P by 8. Minus simply indicates that the direction will be opposite to what we have assumed. And RAH will be equal to a similar value as RBH, which is minus 1.5 P by 8. And similarly to RBH, we have assumed a wrong direction for RAH and it will be in the opposite direction. But here, since we are asked only about the magnitude, it will be P 1.5 P by 8 and 1.5 P by 8 for the three reactions. So the magnitudes of RAV, RBH and RAH were found to be P 1.5 P by 8 and 1.5 P by 8 respectively, which is option D. The relevant NPTEL reference has been mentioned.